QSO Today, episode 208, Ulrich Rohde, N1UL. This episode of QSO Today is sponsored by ICOM America, makers of the finest HF, VHF, and UHF transceivers for every level of amateur radio operator, and by QRP Labs, makers of the QCX single-band transceiver kit. Please support the QSO Today podcast by supporting these fine sponsors. Welcome to the QSO Today podcast. I'm Eric Guth for N1UG, your host. I'm delighted to have as my guest today Dr. Ulrich Rohde, N1UL, who is a pioneer in RF oscillator and receiver design with over 60 articles over the last 40 years to his credit in just QST and QEX magazines alone. Dr. Rohde has had a significant scientific influence on his family company, the Munich-based Rohde & Schwarz Test Equipment Company, and amateur radio manufacturers like ICOM. If you'd like to get into the fundamentals of oscillator and receiver design, then you will enjoy my QSO Today with N1UL. N1UL, this is Eric for N1UG. Are you there, Ulrich?
Yes, I'm fully here.
Great. Ulrich, thanks for joining me at the QSO Today podcast. Can we start at the beginning of your ham radio story? When and how did it start for you?
I think my first interest in ham radio started because my father had a ham radio license. His callsign was DJ5 London Radio. At the time, he drove an American car with a big whip antenna, a Collins KWM2 built in. From today's point of view, somewhat of a complicated issue. And so I kind of, looking at the operation and see this, I became curious. I played a little bit with the crystal detectors to hear the local AM station, but I kind of followed my father's activities.
So did he guide you in your education towards amateur radio and getting your first license?
No, he didn't need to because I was curious what this all meant. And so I picked up the literature, whatever was available in 1956. I don't remember all the details, but ultimately I found myself at the German post office applying for the test and for a license.
And so your first license in 1956, 1957?
56, yeah, correct.
And what was your first call sign?
First call sign was DJ2LRX with an X at the end.
Was that a regular license, or did they have something similar to the American novice license in Germany?
Yeah, this was similar like the novice. This was a VHF, UHF license. Because the first thing I did, I flunked the Morse code.
And so what happened after that?
Well, for a long time I stayed on the VHF, UHF, and then ultimately I got angry at myself and upgraded to a regular Class A license, which is equivalent to the German, to the American extra class license. And when I moved to America, I had to retake all the license again up to extra class license.
With the code?
Everything, yeah.
Yeah, how about that? Can we go back to your father for just a second? I saw a slide in a presentation where you were mentioned that you might be related to the Rohde & Schwarz Test Equipment Company. Is that your family?
Yes.
So your father, the reason he drove an American car and had a Collins KWM2, was he the founder of Rohde & Schwarz?
Yes, together with Dr. Schwarz, the two, yes.
Wow. Well, that's pretty amazing. For those of us who love test equipment, we know Rohde & Schwarz pretty well. So you actually had quite a technical tailwind, I would guess, in your life. Did ham radio then at that point then play a part in the choices that you made for your education and career?
Initially not. No, it was just physics. And I liked the hobby. I liked to be able to talk to people. I had a few days to go to get the high school diploma, so not really. It was too early.
It was too early. So you actually took your degree then in physics?
High school diploma was a few years later. So at the moment, I was just enjoying the ability to talk to people in Europe. I really didn't care too much about the inner workings of the radio. I liked the communication ability.
So I see. So in those days, in the late 50s, you were operating on VHF and UHF, as you'd said earlier. What modes were you operating in VHF and UHF?
We had amplitude modulation at the time. FM repeaters came much later. And for a while, I had a Geloso American 2-meter single sideband radio in my car. Very few had it. It was funny to drive over the mountains, and I liked the single sideband operation from the car. Of course, today you don't get anybody anymore.
So you were operating 2-meter AM from your car?
And single sideband.
And single sideband. Well, that's pretty cool. And were you using like a quarter wave antenna or something like that on the roof in those days?
I guess, yeah. I forgot the detail, but it was probably had to be quarter wave length antenna on the car, yeah.
Well, when I think about it, I mean, it's actually kind of amazing when you think about operating 2 meters without repeaters in the countryside. That meant that there was actually people to talk to. And the band, was it popular in those days?
Well, Germany is very hilly. So there were many highly elevated places, and a lot of people were living there, and they had big antennas. And yes, between the Swiss Alps, the Austrian Alps, and the Bavarian Alps, there was enough activity. You could, 400 miles and so, radius, get contacts from the highway and so on, and 2-meter single sideband. That's correct.
Are you active now on the air?
Very much, yeah.
How did that evolve? I mean, you came to America in what year and went through and retested for all the licenses. When did you come to America?
Well, I moved to America in 1974. And the very moment you get an American passport, you lose all your visitor's privileges. So I had no choice but to retake all the tests. My first American call sign was KA2WEU, pretty lengthy. And then a friend of mine gave me so much headache because the call sign was so long. So I applied for a vanity call sign N1UL. And the Morse code, I flunked in 1 week the test 3 times. The final day I finally passed. It was 9 out of 10 correct. And in the room next door, they were singing Christmas carols full blast, and I had my ears full with the Morse code and the singing, and then the table collapsed, and I was writing the letters on a piece of paper in the air, and I got so stressed, I ultimately decided not to drive home, but to the airport. I don't know why I drove to the airport, but I drove to the airport after I passed the test.
Left America?
No, I just went to the airport, and then I found...
Oh, okay.
And I didn't know why. Then I realized I went to the airport, and I turned around. I had no idea why I did it when I went to the airport. It was funny. I remember this, yeah.
So after your high school, where did you study? And what did you study?
I studied essentially what you would call radio communication in Munich and in Darmstadt. Munich is a very crowded place, and so I went to this much smaller place in Darmstadt, which is northern of Munich, yeah.
And you attained bachelor's and master's degrees and equivalents. You have a PhD as well. All of that from Germany?
Yeah, I have 2 PhDs from Germany, American master's degree. I have a mixture of different things, and some are honorary degrees and some are what you call earned degrees. I have a mixture of these things, yeah, that's correct.
And did you pursue, from the very beginning, a career in radio communications? Yeah, I think this radio communication is probably the closest, because radio communication at the time meant all the things we split today. I mean, everything what you can do with a cell phone would fall at those days under radio communication. Can you speak about your early work in radio communications? Maybe from Germany and as you came here, and what you were pursuing?
Well, I think one of the first almost negative experience was I worked for AEG Telefunken in Germany. At the time, the military communication was forbidden to be done in Berlin because of the Soviet English, French, and German situation there. And I was in charge of manpacks and similar things. And I had a house pretty high, 19 floors, and I couldn't hear the Canadian time signal because the receiver was so lousy. So it took a while before I understood that preamplifiers are not what you want, and firsthand, besides mathematics, I realized that intermodulation distortion can kill you and what sideband is. There's a difference whether you read these things in a textbook or whether they get you in trouble. So this was most exciting for me in real time to see what the consequences were. And I remember that I gave away about 100 or so AGC pin diode attenuators for the Yaesu FT101, which you could put in the front end, and then the thing became infinitely better because rather than have a preamplifier there, it had an attenuator which adjusted to the signal to noise ratio you needed, and all of a sudden these radios were very powerful. The concept of dynamic range really wasn't understood in these days, but that's the thing I came up with, and I probably built the first fully solid-state manpack with an automatic antenna tuned everything you needed. So this was the result of being snowed in on a ski adventure in Italy. We had so much snow, nothing to eat, a few candles and nothing to do, so a group of friends and we said, what do we do? So we came up with a concept of a manpack as a competition to the PRC 104.
Really? And what was this manpack? This is made by Telefunken.
AG Telefunken, yeah, that's correct.
What was the model number of this manpack? I mean, we may have some listeners who are military manpack collectors.
Yeah, I'm fully with you. I just have to find it.
While you're looking it up, you were very hands-on then in terms of this equipment. You actually took it home to your 19th floor apartment and tried it out rather than stay in the lab with it.
Yeah, that's correct. And here it comes. It's called an AEG 6861/12 MOD. And you can find the details on www.kpju.e_AEG.htm. Yeah, that's the manpack. It shows also the picture of us. We invented this. This, as I said, was the world's first fully automatic antenna tuner, 20-watt all-mode single sideband, and had a interesting voice processor. This was really much better than the PRC 104.
About what year was this? This was in the late 60s?
Yeah, 68, yeah.
You stayed then with AG Telefunken for a number of years, and then you came here?
Yeah, I was kind of forced to go to America before because my father found out that the people who ran the American RNS division were about to retire. And so with not much notice, my father said, go and fix it. So that's what I did. I went and fixed it.
And never came back?
I did not come back. First of all, America is the land at the time, specifically, of many opportunities. And in Germany, if you want to go anywhere, you have to have a lot of connections. You have to have the right age and all the right credentials. And if you have a very famous father, then the father's in the way, because everybody measures you against your father, but not yourself. You kind of disappear. And I didn't like this, so I ran away, and I was happy to go. And then when the RNS operation grew in size, I joined the RCA Corporation in Camden. Now, first, I ran my father's company in America, the Rohde Schwarz Corporation, in Clifton. And then, after we moved this to Long Island, and I didn't want to travel to Long Island, I got a job offer to run the electronic specialty department at RCA in Camden,
Now, RCA was involved at that time also in the space program. Was any of the space program communications being done there in Camden?
No, I was in charge of military secure communication.
And how was it evolving then in those days? Were they at the point of like frequency hopping, spread spectrum, and things like that in those days?
Yeah, all these things were discussed. My team probably developed the world's first really working software-defined radio. I mean, a lot of publications were done about proposing things, but I think we had the first one that actually worked. And I gave a classified presentation in England, highly classified actually, about these things to do. And the limitation were the microprocessors, and this Cosmic processor from RCA. It's a computational limitation, was kind of limiting the technology and the speed, but it was a computational problem. The architecture hasn't changed much.
Really? And about what year was this? Because when we think of software-defined radio, we're thinking we're thinking not the late 90s. We're actually thinking in the 2000s for this, right?
Well, I published a book about radio communications in around 1985. And this already had some of the beginnings where I was allowed to publish in there. So in the beginning of 1980, we already had a running radio.
Really? Oh, how interesting.
Yeah, well, the thing was paid from the American government, so there's a limitation what you could publicly do.
Well, I remember, I think it must have been in the early 90s, digital signal processing was beginning to take off, probably as a result of the computer era that we were also in. Did you spend a lot of time in software design radio after that?
Yeah. One of the tricky things we did is automatic single sideband carrier tuning. So if you don't know, if you find a single sideband, you never know what the exact frequency is. So we developed a method how to define the 60 hertz residual hum on a signal and tune the receiver. We've done some crazy things, and also invented what I would call today the composite filter. In analog, you can also make a Bessel filter, Chebyshev filter, a linear phase filter. You can do all these things. But in mathematics and digital processing, you can put a lookup table together with a very fast lookup table. And so if you take a 400 megahertz clock frequency, you can reclock the signal, and you can composite a filter which mathematically exists because it has the components of a linear phase filter and then a Chebyshev or elliptical filter. You can do filter which in reality don't exist. That's why it's called composite. You put the mathematic coefficient together as you need them.
Well, that's pretty amazing.
The reason why I do this is then you can avoid the ringing, the Gibbs phenomenon, the ringing CW filter, which has been in the literature very often, was due to the misunderstanding that a brick square filter was the better choice. Arthur Collins did it right. He had a round filter and this had minimum ringing. That's why the Collins filter and Collins radio sounded so much better. The engineers later came up with the kind of silly architecture to make a square type of filter. And the group delay at the ends causes rings, so that's why these brick filters, as they were called, are terrible. And the round filters were much better. And the ideal is a composite filter where you put the mathematics of all worlds together. That's the correct answer. But you can only do this in DSP.
And now let's take a moment for this message from ICOM America. Heard it, worked it, logged it. It's time to get the ICOM transceiver that is best suited for your lifestyle. ICOM offers a variety of high-performance and innovative transceivers that fit your ham radio budget. See how you can make the most out of contest season with one of these fine transceivers. The IC7851 has the competitive edge that you've been looking for. Raise the bar and hear what others cannot with this flagship HF and 50 MHz transceiver. This is due to ICOM engineers focusing on new local oscillators design that drastically reduces phase noise. This noise reduction and purity of LO results in an RMDR of 110 dB, allowing you to hear the extremely weak signals, making the IC7851 the perfect rig for making contacts at the bottom of the sunspot cycle. In addition, this fine rig has reciprocal mixing dynamic range, crystal clear LO design, spectrum scope, dual receivers, and a digital voice recorder. The IC7610 is the SDR every ham wants, and just in time for contest season. This high-performance SDR has the ability to pick out the faintest signals even in the presence of stronger adjacent signals. The new ICOM 7610 is a direct sampling software-defined radio that will change the world's definition of an SDR transceiver. Its features include an RF direct sampling system, 110 dB RMDR, independent dual receivers, and dual digicell. The IC7300 has changed the way that an entry-level HF transceiver is designed. This rig is a high-performance, innovative high-frequency transceiver with a compact design that will far exceed your expectations. It includes RF direct sampling, 15 discrete bandpass filters, a large 4.3-inch color touchscreen, real-time spectrum scope, internal antenna tuner, and an SD card memory slot. So no matter which ICOM rig you choose, you'll be a winner. Be sure to check out these fine rigs at www.icomamerica.com, and when you finally go to make your ICOM purchase, be sure to tell the dealer that you heard it here on QSO Today. And now back to our QSO. I saw when I was researching this episode of QSO Today that in 2015 you were awarded the prestigious II Robbie Award that recognized your outstanding contributions in the areas of atomic and molecular frequency standards. This is causing me to probably go back in your background. In the background info that was in this article, it said that your fascination with oscillators actually started when you were a teenager. I see how all of this is going together, but can you talk about oscillators? You seem to have written the majority of the articles that you published in at least QEX on oscillator and oscillator design. Can you tell us what fascinates you about them and also how they've evolved over time?
Well, the first oscillator I built was kind of illegal because I built a super regenerative receiver to listen to the German police in 1952, and I used a pentode, and the super regenerative receiver transmits and receives at the same time, and that's how I built my first oscillator. And it made a lot of noise. Of course, there were many super regenerative receivers in 1950 and so later in QST, but that's how the whole started. But much later, being at AEG Telefunken, I saw the impact of single sideband noise of the oscillator. I mean, it takes a while to understand that these oscillators are noisy and that they make noise in the adjacent sideband. And therefore, the single sideband noise of an oscillator suppresses a weak signal next door, so to speak. And there's a difference whether you read these things or whether you experience them, and that's what started my interest in low-phase noise oscillators.
I see now that we're now buying frequency synthesizer chips for $2 mounted on circuit boards. How have oscillators evolved in your world to this point that we now have $2 chips?
Yeah, that's a double-sided sword. My position is the quality of an oscillator has to do with the electric Q of a resonator, and the electric Q is more or less proportional to the volume the tuned element takes. So if the highest Q for an inductor is if the length of the inductor is 3 to 5 times longer than the diameter. By the time you reduce the inductor to a piece of stretched wire, the Q is essentially useless. And so the oscillators which you put on a chip have an extraordinarily low Q, and the way to rescue the situation is you take a PLL phase-lock loop system, and within the loop bandwidth you clean up the noise of the oscillator. So what you see at the output is not what the oscillator does itself, but you see the cleanup mechanism of a phase-lock loop, but outside the loop bandwidth it's lots of garbage. It's a big compromise, and it depends what you want. If you want to have the best, you have to do it discrete. If you want to have something which is fast and dirty, you do it on IC. A good negative example is the GSM telephone. Initially, the base stations were supposed to use every second channel, but the phase noise wasn't good enough. So the GSM signal uses the third channel. Each channel is 200 kilohertz, so the third channel is 600 kilohertz away from the carrier. And finally, the phase noise of these oscillators, 600 kilohertz away from the carrier, was good enough to avoid the interference of the adjacent channel phase noise. So you lose in distance one channel, and you need more base stations. Now comes the economic question: what would have been cheaper, to fix the oscillator or to build more base stations? In my opinion, the economics lost, and now you have more base stations and poorer radios. It went just the opposite how it should be done.
Right, although I see that GSM is going away in many places and being replaced with, pure digital, LTE, and probably, 5G in the future?
Yeah, if you do a frequency time slot things, that changes, but there are still enough old cell phones available. But the major drawback of these digital telephones is that in analog, the human brain can still put some things together. If you say something like York, and everybody knows you are in New York in the vicinity, the human brain gets the New York word back together. And the bit error range, if it's beyond a certain error, it cannot recover. You lose the contact. So while you can get more channels on the digital, the signal-to-noise ratio quality requirements are much worse. So you get smaller distance, which you pay. You can have more stations, but you have less distance. And I remember when the first tests were done in New York, because of the reflections in the buildings, it didn't work very well. The analog system outsmarted the digital because of the bit error rate problem. Nobody understood this. So digital is not always the answer.
Were you involved in the cellular telephone industry, from its infancy?
Yes, with the base station a little bit, but the base station then requirements became so cheap, and as I explained, then they eliminated the channel 2 and they went to the third 600 kilohertz away, and then the CMOS oscillators as a chip were good enough for the purpose. And in my company, we are trying to avoid CMOS oscillators. They're just too noisy.
Now, you've published over 60 articles for QEX and QST over the years. Has your approach to receiver design then changed, and is that based on the availability of components?
Well, it certainly changed over the years. I mean, the fully digital receiver with an analog digital converter is only feasible for the last 10 years to have a good performance. I mean, the initial chips were not good enough. To give you a few numbers, the noise figure of a analog digital converter is about 20 dB noise figure. I mean, this is useless. So you need a preamplifier. And the analog digital converter is an integrator. So if you take 1 million signals at 1 microvolt next to each other, if you multiply the two, you get 1 volt. And then the analog digital converter is dead. Nothing works anymore. So you need much more pre-selection and filtering. The 3 dB per dB mathematics for a double balanced mixer is much more useful. The real advantage, in my opinion, is the numerically controlled oscillator. But in as much as the receivers have vastly improved, you have enough dirty transmitters on the market, and all the old transmitters which have poor splatter capability are disasters. So I think the point has come to stop worrying about receivers, but clean up the transmitters.
Do you think that the ham radio transceivers that are being produced now in the marketplace, do you think that they are outperforming the older radios, maybe with the exception of the Collins radios, but outperforming those radios for the, I'm trying to think, the bang for the buck?
Let's go back to the Collins. The Collins radio, because of the mechanical filters, which were very round, had the best sounding. It was not the greatest in dynamic range, or overload problems were there also, but on a quiet evening and not too many aggressive signals, this was the best sounding because of the shape factor the mechanical filter had. The transmitters in grounded grid were certainly much better than things to do today. The neutralization and feedback they used on the power amplifier with up to minus 46 dB below carrier distortion are unchallenged. I mean, these old tube things were simply better. It went from minus 46 typically down to minus 32, which is a very huge disaster. And the quality of the transmitter have not caught up by any means. So if you look at the quality performance, I would certainly look at the transmitters. And there's some interesting discussion, what's better, a field effect transistor or a bipolar transistor. The field effect MOS transistor is a very good choice, but only lately can you get these transistors which are good enough. I think if you go back 5 or 6 years, they still weren't good enough as you what can do today. Good progress has been made, but you have to do it right.
But when we're talking about these new field effect transistors, are we...
LDMOS. They're called LDMOS, yeah.
Oh, LDMOS, okay. When we're talking about these components, do you think they're a spin-off of the proliferation of microwave devices and cell phones and everything else? And are we talking then about the characteristics of microwave-type transmitters now, or are we down still in HF?
We are still down at HF. The LDMOS, the way they're made, are not useful above 500-600 megahertz. They're better device, but for lower frequency, linearity, and high voltage, I mean, the smaller the transistor gets for higher frequencies, the lower the breakdown voltage gets. So the optimum up to 50 megahertz are these LDMOS. I think there's some exotic ones which can at best go to 400 megahertz, but that's the end. And these I wouldn't call microwave devices. These are very good power device optimized for this frequency range. If you go up to the microwave range, 10, 30, 50 gigahertz, the world has changed. Total different things.
So what kind of transceiver does N1UL use nowadays? If you're looking at your shack, what do you have?
That's a loaded question.
Of course.
It's a loaded question. Number one, ICOM gave me a 11850, because I help them with some things, and I don't want this to be construed as an advertising. That's why I'm hesitant.
Well, ICOM is a sponsor, so you must know ICOM America is a sponsor of the QSO Today podcast.
The high-volume version is called 51. They gave me serial number 1. And so in my opinion, this high-end, I think $12,000 or $13,000 radio on the market is the absolute best. I'm sure that the people from Flex Radio and others will disagree with me, but I think from an architectural point of view, this is the very best. It has a numerically controlled DDS type of oscillator. The phase noise of this thing is unchallenged. It's just superior to anything else. And also the transmitters of high quality. It also uses the old concept, which means it has a input filter. It mixes up the frequency to a VHF frequency somewhere around 50, 60 megahertz. Then use a few kilohertz crystal filter, and so the analog digital converter which follows is protected by the 3 kilohertz bandwidth. And that still is and will be the best way to do it. Any other way, by putting a wider signal to the analog to digital converter, has the drawback that it deteriorates the quality. But it's much cheaper because you avoid the entire front end. So if money is the issue, then you take an ICOM 7300 or whatever these things are. But if you want to have something which is unchallenged, then the higher price radio is the only answer. It's an architectural thing here, and you just can't do any better. And on the other hand, I use most for my ham radio on shortwave. I use my own company radio, which is a military system for frequency hopping and things like this. But because of the frequency agility and hopping and all the things it does, it strangely enough is not as good in some aspects as the ICOM radio. There's a contradiction. Very fast switching of frequency hopping and things like this. Switching speed contradicts some of the phase noise. So you can have either or and not both at the same time. That's an architectural question. So the RNS radio with 1 kilowatt output is my favorite. It has the least number of knobs and works very well and does everything it can do. But from a performance, if it gets crowded, I always would take the ICOM radio, there's no question.
Oh, that's pretty amazing. And the reason that this feature, these numerically controlled DDS, is not available in lower price radios is that this construction technique is expensive?
Yeah. It's power hungry and yeah.
It's not a field radio. It's a radio that sits on the desk.
Correct. I think the AD9914, if you take a look at the data sheet of the AD9914 and the whole series, starting from 12 to 14, if you look at these analog digital converters, then and they are DEX, digital analog converters, and they generate all these frequencies. It's a complex issue. You have to have a clocking frequency, which is in the gigahertz area. It has to be twice as high as the output frequency. So if you have a frequency of 50 megahertz output, then you're better off if you have a clock frequency of 250 megahertz to clock the DDS, and there are all kind of peripheral things necessary, and not to have any spurious sideband. So, but that's the right way to do it. And you can, and I gave a presentation on this at the university, you can today do in pure mathematics a better signal generation than you can do in the old-fashioned analog. That's the amazing thing. The analog free-running oscillator, as we know it, is noisier than what you can do nowadays in mathematics.
Now, do you think that the digital modes, the Joe Taylor digital modes, have created the ability for us to actually create cheaper, maybe poor performing receivers, but because we're able to recover the data way down in the noise, that we've kind of gotten around the issue of having to have a really high performance receiver?
Yes. At the moment, the sunspot cycle is low. I think what we have at the moment is unrealistic. Plus, all the propaganda stations from the various countries have shut off. So the overload which we used to have in Europe has disappeared. But the Joe Taylor method really loses the person-to-person interference. You exchange numerically numbers. It's like one computer talking to the other. And
right.
Nothing against Joe Taylor. He's an extraordinary gifted and nice gentleman. But I prefer them with all the possible interference. A regular discussion like you and I have on this telephone, which occasionally makes some funny noise. I prefer this because it's a real life, and you get all the emotions and everything comes across the telephone. That's really life. And a sterile exchange of numbers, I think, is for me not attractive.
So your favorite operating mode then is single sideband, maybe even AM?
AM I call it antique modulation. Takes too much bandwidth, goodbye to it. But the single sideband, yes, that's my preferred modulation.
And now this message from QRP Labs. Hans Summers, G0UPL, informs me that he has sold over 5,000 QCX transceiver kits. I hope that in large part this is due to the promotion on the QSO Today podcast of this amazing single-board transceiver kit for under $50 from QRP Labs. The QCX is a feature-packed high-performance single-band 5-watt CW transceiver kit with whisper beacon and built-in alignment and test equipment tools. It is available for 80, 60, 40, 30, 20, or the 17-meter bands. It has a rotary encoder synthesized tuning, VFO A-B split, iambic keyer, CW decoder, and more. You can assemble this kit yourself with standard tools and a soldering iron. There are no surface mount components to solder, as the two SMD ICs are already factory pre-soldered on the board. Of course, Hans has a whole range of accessories to trick out this ride, using the language of hot rod cars. Since Hans has shipped over 5,000 QCXs, there is a rapidly growing community of builders and users who are fine-tuning the QCX in an open-source kind of way and sharing it with us on the Internet. So if you're ready to build your own rig, or want to save money, or just want that prepper rig for your bomb shelter, use the link on this week's show notes page to get to QRP Labs. Please use my link as it tells Hans that you heard about it here on QSO Today. QRP Labs is my favorite kit company. It should be yours too. QRP Labs. And now, back to our QSO Today. And where do you hang out? Are you a contester or are you a DXer? What's your favorite operating mode?
My favorite operating mode is take a telephone, call some friends. Are you having time? Let's meet on the air, and then I go on 20 meters or 18 megahertz, and then we have a roundtable discussion of various topics. But I initialize these things by placing a telephone call and saying, is the propagation there? Can we talk to each other? And my favorite bands, depending on the time of the day, between 7 megahertz, 14, and 18 megahertz. At the moment, the higher frequencies are dead, but these three frequency bands are ideal.
Well, that's pretty cool. And you don't have to do a one-ringer anymore to get people on the air. You can actually just call them up and say, I'm on 18 meters or something like that, right?
Well, I cheat a little bit. What actually I'm doing is I take WhatsApp. Many of my friends have a WhatsApp connection. So I cheat and send a WhatsApp connection and say, how about? And then I give a frequency. And then it works or not. So, but that's how I do it, yeah.
That's pretty cool. Do you operate any of the UHF, VHF digital modes like DMR or FM or anything like that?
I own several repeaters in Munich, here in New Jersey and in Florida and the Swiss Alps, which I donated to the Ham. But I don't like these endless chats with very little contents on the repeaters. You have to have a special need for these things. Sometimes I hang around with the spider net at 14.347 in Mark Island up here, but not that often. And I have ability up to 1296, but single sideband.
I see. All single sideband.
Yeah.
Well, that's pretty cool.
I used to be pretty good at Morse code, but it's too slow. I mean, it takes, before you set everything, I don't have the patience.
So when you do your round table on HF,
yeah,
what's the topic of conversation?
Similar what you do and I do at the moment here. We talk about where things coming from, where do they go, and what's needed to be invented, so to speak.
You're a pioneer, and you're a descendant of a pioneer and leader in RF communications, both commercially and in amateur radio. What is the state of RF design these days, and who's doing it?
I cannot answer the question in the form you've asked it, because I'm not sure how you define the state of the art. I mean, my interest lies in generation of signals. We talked about oscillators. I explained why oscillator noise is an issue. And the things which my friend A.J. Potter, who I locked into a room, took the key away and said, no meal, no toilet, you have to pass the extra class license, which he did. He and I work on physics, on extremely modern physics-based oscillator, on what's called metamaterial structures. The metamaterial is a material that does not exist in nature. It relates to a structure, and only to a structure. It's no material. It's a structure which, in an evanescence mode, reflects waves. And the best explanation is you have a gain bandwidth product, and so if the gain bandwidth product is constant in a passive device, what you do is you reduce the bandwidth, and then the amplitude gets higher because the product of both remains the same. So you can get a Q multiplier or increase of amplitude in a resonance system, and you get Qs beyond the wildest dreams, and you can build oscillators at low phase noise beyond the wildest dreams if you know how to invoke this evanescence mode in passive structures. And that's something we're doing successfully now, and which outperforms everything has been invented before.
And you're doing this at Synergy Microwave, where you're the chairman of the company?
That's correct, yeah.
I'd like to talk about Synergy in just a second, but I want to go back to my question. You're lecturing in universities now. Are you seeing in the universities people like you were, at the time, interested and highly motivated in the area of RF engineering and oscillators, receiver design, transmitter design? Are those people there? Are our young people coming into this area of the profession? Yes,
and many are more gifted than I am. I find there are people who are much better in mathematics and much better educated. I'm on my way out, so to speak, and people have now more in mathematics better tools than I've learned. And yes, I've seen people who are extraordinarily gifted, and one of the things I've done is I have established a monetary fund where we give money to gifted students which couldn't afford certain educational things, and pay for parts of the education. I think I deserve. They deserve help from people like me. That's the correct sentence.
Oh, I think that's amazing. You mentioned just a minute ago that that you're the chairman of, or maybe I mentioned it, that you're the chairman of Synergy Microwave. That's your company. It has an amazing online catalog of microwave components. If a ham wants to start his exploration of microwave, is Synergy Microwave a catalog? Is that a good place to start? And can you recommend, if that is a good place to start, like a parts list of basic components that somebody could have to put together a microwave laboratory?
Yes and no, because we are trying not to be a low-cost company, but we are trying to be a high-performance company. And for reason of economics, we typically have a minimum order, not so much quantity, but amount of money. If it's less than, let's say, $100, we wouldn't take the order. And this, of course, is not good for ham radio because they need one mixer, not 10. So from a technology point, we can be a great help, but from a source, we are not useful because we cannot handle financially useful small orders. But there are distributors and other companies who address the needs of individuals much better. And that's to a degree. I mean, people have asked me all the time whether I ever built a power amplifier. I said, no. First of all, it's so much mechanics and less electronics. And by the time you buy all these things in one single piece, and you have paid shipping cost, and you assemble the whole thing, it costs more than when you buy it. And so some things which are useful to build and some are not useful to build. And likewise, with my eyes, I couldn't solder SMD devices anywhere. So from our contents, yes, we have nice things, but as a supplier to the radio amateurs, the answer is no.
Are you involved in 5G cellular telephone development?
Yes.
Can you say how you're involved and what you think that's going to turn out to be? The
way I'm involved is that our family company, Rohde & Schwarz in Munich, generates signal generator which you need to measure these future telephones. And you have to generate artificial signals like multipass, distortion, and things like this. You have to be able to generate signals which come close to reality, and you can see how the algorithm in those radios perform and how the antennas work. So yes, we generate a whole suite of signal generator and test equipment, spectrum analyzers, up to about 100 gigahertz, which are useful for this purpose. And it's a mixture between mathematics, firmware, software, and it's driven by the complex situation. I mean, give you a typical example. If you drive around in Manhattan, and if you want to talk handy-talkie direct to another handy-talkie, you most likely talk via reflection. And so if you cannot penetrate a building, it doesn't go through, then you have a delayed signal. You can have two reflections, one from the left, one from the right. They can either kill each other or they can enhance each other, or there's a phase shift, and there are all kinds of things. And in these radios and these telephones, there's something called a training signal. The receiver, the system gets told what things going to happen, and then they do phase adjustment. These are very complex mathematical things, how you deal with the signal. And yes, to generate those frequencies up to 100 gigahertz and to do it well and to do low phase noise, yes, we're involved in this.
And as you just revealed, you're still involved in Rohde & Schwarz. Are you on the board there, or are you still in management there? By definition.
By definition, well, we don't have a formal board. 4 times a year, the owners of both families meet together, and we discuss what things we need to know. It's mostly an informal session because we have a very capable management, and contrary to some other companies where the heirs, which essentially I am, are at war with each other. All of us are very peaceful. All the heirs of the Rohde & Schwarz founding people have their own jobs. They don't live off the heritage, but we have our own things, so we don't need the income, and we leave the money in the company to secure the well-being of the employees, and we have zero liabilities. We cannot be blackmailed by any bank. We have no liabilities in any form, money-wise, from any bank. None.
Well, that's pretty amazing.
We can buy the bank, but the bank cannot tell us something.
I think Craig McCaw, who was one of the early cellular telephone pioneers in Seattle, Washington, once said that when you owe the bank $50,000, you can't get them to return your call. But when you owe the bank $10 million, they always return your calls.
Well, my joke is the reason why Julius Caesar got killed was because he paid his liability to the bank. If he had been a bank, he would have survived. That's my equivalent take to what you just said.
Yeah, I think you're probably right. You're a sailor and have a sailing yacht called the Dragonfly. You have some beautiful pictures of it online.
Yeah, these are 2 words. Well, it says dragon, fly means take off. It's not the dragonfly, the insect.
Oh, and it's not the dragonfly like a dragonfly. It's dragonfly.
Yeah, dragon, space, fly, take off. We won the race in Antigua twice. And the cost of one race is $50,000. And your payback is a piece of metal, silver-plated with your name on it. And it's just not worth it. So once you know how it works, I said, let's do something else. It's a waste of money. And I can do more useful things for the community than fly 10 people to Antigua and win a race. So I've stopped doing this.
Where have you been on your ship? Have you gone around the world in it?
No, I'm too timid. I don't get seasick, but I must admit I would be too timid to go around the world. I don't think I would like this. So the most I've done is in the Caribbean and down to Antigua, things like this. The nice thing about sailing is for hours nothing happens. The wind is steady, and you can lean back and think the things you never had time to think about. And at the same time, I have probably the most advanced ham station on the sailboat. I have two sailboats. One is a Beneteau 47, and one is a Swan 53. And I probably have the most advanced ham radio shortwave station on the boat. And so it's fun to talk to people in the world and sit there and sail and think things through for which you normally have no time. This I like. You have to. Nobody can call you. You have a piece. Think, what would I like to do? How do I solve a problem?
So that's a good question. I hear this in a lot of podcasts when people talk about, maybe personal or business success. How do you, if you're not sailing, how do you lock yourself away in order to do some deep thinking? What's your escape mechanism if it isn't your ship?
I spend most weekends in reading latest scientific papers. And as many people, I can do multitasking, which means on the surface, I'm reading something of interest, but then the below layer of the brain works on things and takes keywords and solves puzzles. And I don't have any better way of explaining this. But out of certain things I do, I come out with a solution. It's just like a light bulb goes on and here's the answer. It's a slow process. You cannot force it, but it has to go. It takes a certain amount of time before things get ripe. But certain things you cannot force, have to develop in your mind.
And it's not related necessarily to the paper that you're reading.
There are some common denominators because the individual may have a similar or related problem, and he comes up with a solution, but there are sometimes common denominators, and then you find something which fits, and then you take the advice you find there.
I see. Ulrich, what kind of impact has amateur radio had on your family life?
Everybody in my family and everybody who reports to me in any higher function must have a ham license.
Do you have a wife who has a ham license?
Yeah.
Children?
Yeah.
All of them?
Yeah. Yeah.
Yeah. Good for you.
Even the top manager of the Rohde & Schwarz company had a ham license.
Well, that's pretty cool. And do you actually communicate over ham radio to the people in your life?
Yeah, the more distant one, yes. The other one, I can see on a daily basis.
Well, but it gives her, as a result of having the ham license, it gives her an appreciation of what you're thinking about, perhaps.
It also gives people understanding what certain things mean. And so if you talk about, let's take synergy microwave. I take care of some technical things, and my wife runs the daily operation. What this means is she looks at our products for what's in it, what they cost, and what's possible. So the ham license has helped her a lot to understand the costing and what a mixer is, what a resistor is. You get a basic understanding. So even if your background is in economics, but now you know what we talk about. And I mean, I have a similar opinion. You cannot design a car if you don't know what torque is, if you don't know what tire is, how you get the horsepower on the street. You need a certain education and practical experience with driving a car before you can design one. And you cannot run an electric company if you don't have experience what these things mean in real life. And that's my opinion. If an attorney or a pure financial man runs a company, he will never have the same success as somebody who is close to the real problem. And the other opinion I have is, which is probably not shared by many of your listeners, the fact that you own something does not mean you're the best one to run it. So I'm quite happy that the 10,000 employee and $2 billion sales company Rohde & Schwarz is not blessed by my present running it, but is blessed by me giving scientific input, because there are certain people who are better hard-nosed and better to run a complex thing like a company better than I could have done, because I come from technology and not from management. These are different abilities, and I like what I'm doing, but I'm trying not to do things I'm not good at. So I find you separate what you own and what you do. They are not related.
Well, you keep throwing out these pearls. I
do what?
You keep throwing out these pearls of wisdom. I'm sitting here thinking, well, that must be my problem. I'm great at the ideas, but I'm terrible at management. That's probably why I'm sitting here doing a podcast. I think you're 100% right. What excites you the most about what's happening in amateur radio now?
Well, amateur radio, and I hope I don't insult anybody, for me is a tool to permit me to operate on various frequencies and evaluate hardware. And what the thing excites me most about ham radio is my ability to try antennas and modern communication systems legally on the air and on frequencies. Without this ham license ticket, I wouldn't be able to do. So for me, ham radio is a powerful permit and ability to play with new things and kind of invent these things. So it's like a driver's license, the permit to do something. Most of the things which people now do are already invented. I mean, I have very little mercy why people argue that they lose a few megahertz at 1296. Who cares? Everything you need to know about 1296 has been invented. There is nothing new. Okay, yeah, you try propagation. But essentially, if you're honest, and most people are not, most of these experimental things are known, propagation. There's a lot of things known. But the things which are not known, people don't pay too much attention. Like I said, at the moment, the transmitters are too dirty. If I had the power, I would re-engineer most amplifiers and throw the old ones away and make sure on shortwave you have clean signals. But that's politically not correct what I'm after. So for me, ham radio is a legal playground to test things and optimize them legally.
Wow.
Make sense?
Yeah, oh, absolutely. I think you're right on. For those of us who grew up in ham radio, yeah, it's an amazing playground. I think that some of us may underestimate, its value. What advice would you give to new or returning hams to the hobby then?
Well, I would give them the same advice which is valid for me. Over the weekend, occasionally I go on 20 meters and point west and see who I like to meet in Italy or Spain or somebody, and talk to people and get an opinion which doesn't follow the local news, and I can exchange ideas. For me, it's a human interchange permit to talk about things of common interest, and people are much higher educated than many years ago and have more opinion. I find it fascinating to learn and understand opinions, why people think the way they do, what things they don't like, and how to get orderly systems. And I mean, the funny thing is, when I was in school, the ham radio did two things for me. It improved my English, which was at the time, of course, questionable, and it helped me in geometry. No, not the word. See, my English just failed. Which city is where, and how things fit together. I mean, all of a sudden...
So it improved your geography.
Geography, yeah, that's the word I'm studying, see. My English is far from perfect. So I learned all of a sudden where certain places are and what the distance were. Now I have a much better view. And at the time, 1956, I mean, I knew Italy and Sweden and some things, but what did I know about the Far East and things like this? And I remember I talked to King Faisal, I talked to a lot of highly powerful people in the world. They all don't live anymore. But this interconnect and the ability to exchange ideas, the guys just said, call me Faisal. Didn't say King, he said, just call me Faisal, and we talked about antennas and what he liked and what he didn't like. It was a nice, open conversation, and the ability to talk to other people under no pressure at their leisure in a relaxing way has a higher value than some of these high-pressure news on television.
Well, Ulrich, it's been a wonderful pleasure to speak with you on the QSO Today podcast. I've learned a lot, and I'm going to go back over my notes and just try to figure out exactly how much I've learned. It was really a pleasure to speak with you, and I want to wish you 73, and thank you so much for coming on the QSO Today podcast.
Yeah, likewise, and you asked all the right questions, at least from my opinion. I don't think you forgot anything which is of any relevance, and I thank you for your patience. And my rocky English here, you just missed on one word, but sometimes some words, if I don't use them, I forget them.
I think you were amazingly clear, and as I say, you've given some pearls of wisdom that at least ring home with me. As a kind of entrepreneur over all these years, I think I should have taken your advice 40 years ago. Anyway, I want to thank you again so much. 73.
Yeah, likewise. Bye-bye.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Ulrich. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in N1UL in the search box at the top of the page. My thanks to both ICOM America and QRP Labs for their support of the QSO Today podcast. Please show your support of these fine sponsors by clicking on their links in the show notes pages, or when you make your purchases, that you say that you heard it here on QSO Today. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the other episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes page. I am grateful for any way that you show appreciation and support. It makes a big difference. QSO Today is now available on iHeartRadio, Spotify, Libsyn, and TuneIn, as well as the iTunes Store. If you own an Amazon Echo, you can say, "Alexa, play the QSO Today podcast from TuneIn." I still use Stitcher to listen to podcasts on my smartphone. The links to all of these services are on the show notes pages on the right side. Until next time, this is Eric for Z1UG 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.